Sorry about that, Hires. Somebody phoned me and then it cuts out the video every time. Right, so again, to summarise, you need to know the three definitions, but they are easy to learn because the minute you've got one of them, the other two sort of just fall into place, okay? So you need to know how to explain what a primary, secondary and tertiary alcohol, because it comes up very often, okay? So we'll go through it again. Primary alcohols, when the carbon attached to the hydroxyl group is attached to one other carbon. Yeah, secondary alcohols, when the carbon attached to the hydroxyl group is attached to two carbons, and then tertiary alcohols are when the carbon attached to the hydroxyl group is attached to 1, 2, 3 carbons. Okay? Right, now what we're going to do is we're going to look at a new, oh wait, you can see that. Going to look at a couple of new homologous series. Okay, so from that 5 you learned about the alkanes, the alkenes, the cycloalkanes, alcohols and carboxylic acids. And higher we go into a lot more detail of obviously each one, and then there's multiple more. Okay, so we're going to learn about 2 today. So let's make a wee note here. Aldehydes and ketones are 2 types of homologous series. Okay, so if you can remember the definition of a homologous series, it's a family of compounds that have the same general formula and similar chemical properties. Okay. Now, what's important about these is both contain the carbonyl functional group. And that there is so important. You need to know your functional groups. Okay, so the alcohols have hydroxyl, the carboxylic acids have carboxyl, the alkenes have a carbon-to-carbon double bond, aldehydes and ketones have the carbonyl functional group. Okay, and it looks like that. Okay, so it's just a carbon to oxygen double bond, and obviously because carbon's got a valency of 4, carbon would be bonded to another 2 elements. Right, now we'll do aldehydes first. Okay. Right, yeah, so what was I going to write there? Forget that. So in aldehydes, the carbonyl group is found at the end, or I suppose actually you would call it the start. Okay, so the carbonyl group is found at the start of the molecule. Now, if we just go for 2 carbons, the carbonyl group is found at the end of the molecule, and then we will just put our H's in, like so. Okay, if we have a bigger molecule, Okay, again, if we've got 5 carbons, 1, 2, 3, 4, 5, the carbonyl group would be found at the start, well, the end or the start of the molecule, and then you would just put all your hydrogens in. Two sets, guys. Olivia, can you turn that down, please? Right, sorry. Right, so we've got a aldehyde with 2 carbons, we've got an aldehyde with 5 carbons, but what's important is that every single time this carbonyl group is found at the end of the molecule. Okay? Now, aldehydes are quite easy to name. Aldehydes end in the word anal. Okay, that's how we pronounce that word, anal. So, for example, if we go to this one here, we have 2 carbons. Okay, now the prefix for 2 is eth, and it ends in anal. So this here becomes ethanal. Yeah? Now this one here, we've got 1, 2, 3, 4, 5 carbons, so that's pent. And then it ends in the word anal. So this becomes pentanal. Yeah, so easy. Let's just do... Again, this is one that people don't recognise as an aldehyde because there's only 1 carbon, but again it contains the functional group, and because there is only 1 carbon, it has to be at the end of the molecule or the start of the molecule, and we would just call that methanal. Okay, meth, meaning 1 carbon, and because it's a aldehyde it ends in anal, so this becomes methanal. Okay? Now obviously it can get a wee bit harder when we add branches into it, but it's the same sort of process as we would use if we were naming branches in an alkane or an alcohol or a carboxylic acid. So let's just go for... Let's just go for this molecule. Right, so if we were to name this molecule, again, notice we've got the C double bond O, and what confuses a lot of people with this is a lot of people mix the aldehyde and the carboxylic acid up, because the only difference is a carboxylic acid would have a OH there, so you have to be extra vigilant when you are going through these. Okay, so the carbonyl group is at the end, so we know this is an aldehyde, and then again we start from the side closest to the functional group. So that's carbon 1, that's carbon 2, that's carbon 3, and that is carbon 4. Okay, so on carbon 3 we have a methyl branch. Okay, so if we name the longest chain first, that's 4, so that's bute, and because it's an aldehyde, this would be bute-anal. Okay, and then the branch is on carbon 3, so this is 3-methyl butanal. Okay, and that's it. Now I'll do one more. Right, so draw this molecule and we'll start to name it. So find the functional group that it is. Again, because it's at the end, or the start, sorry, of the molecule, we should instantly be thinking, right, this is an aldehyde, okay? Now, we've got a branch here, and we've also got a branch here, okay? So we've got a methyl branch there, and we've got an ethyl branch because it contains 2 carbons there. Okay, so again we start on the side closest to the functional group, so we start here, so that's carbon 1, 2, 3, 4, 5 and 6. So if we name the longest chain, this would be hex because there's 6 carbons, and because it's an aldehyde, yeah, carbonyl group at the start of the molecule, this is hex anal. Okay, we have an ethyl branch on carbon 4 and we have a methyl branch on carbon 5. Now remember, because ethyl, E, comes before methyl, M, in the alphabet, we would do the ethyl branch first. Okay, so this would become 4 ethyl, 5 methyl hexanyl. Okay, and that's it. That's all you need to know for naming aldehydes. Okay, the important thing about aldehydes is it contains this carbonyl functional group, and the carbonyl functional group is found at the end, or sorry, the start of the molecule. Okay, that is so important. Now what we're going to do, get my other pen, is we're going to look at ketones. Okay? Now, ketones are very similar to aldehydes, just one other wee thing. You probably worked it out, to be honest. So in ketones, again, ketones still contain that carbonyl group. Yeah, so in ketones, the carbonyl group is found in the middle of the molecule between 2 carbons. Okay, so again, if I was to draw this, okay, now this is a ketone. The middle carbon's got 4 bonds coming out at 1, 2, 3, 4, so valencies are fine. That's the functional group there. Okay, and because it's in the middle of the molecule, it's between 2 carbons, that makes it a ketone. Okay, so that's the fundamental difference between an aldehyde and a ketone. The aldehyde, the carbonyl group is found at the end or the start of the molecule. In ketones, the carbonyl group is found in the middle of the molecule between 2 carbons. Okay. Now, ketones end in anone. Okay, so ketones end in anone. So, what does this mean? Again, label your carbons. That's 1, 2, 3. Because there's no other place for that carbonyl group to go, because if the carbonyl group went there, it would no longer be a ketone. Because it's at the end of the molecule, it would make it an aldehyde. Okay, so this one here, because it's 3 carbons, we would call this prop. use a different pen, call this prop for free, and then it ends in anone, so this is prop anone. And that's it. Yeah? Now, you might just want to make a wee note here. Propanone is the smallest ketone you can get. Yeah? And that's because if we went to eth, 2 carbons, it wouldn't matter what carbon the carbonyl group was on, it would be at the start of the molecule, so that would make it an aldehyde. Okay, so the smallest ketone we can get is 3 carbons, propanone, because you need a carbon either side. Yeah? Right. Now, another wee note, and this is important, okay, and this is what people always forget. They remember propanone, but they start to remember what we do after that. So, when... Oh, sorry. Let's go for this one. Before I give you that wee note. Right, so here we are, we've got 2 molecules. Now let's identify there's the carbonyl group there, and there is the carbonyl group there. Okay. These are ketones because the carbonyl group is in the middle of the molecule, it's between 2 carbons, yeah? So that one there's between 1, 2 carbons, that one there's between 1, 2 carbons, okay? Now we start from the side closest, so that makes that carbon 1, 2, 3, 4. If we start from the side closest with this one, that's 1, 2, 3, 4, okay? So what you'll notice, or what you should notice, is these 2 molecules are exactly the same, okay? This one is just that one flipped, okay? Now, because they're the same molecule, well, they've got the same name. We've got 4 carbons, 1, 2, 3, 4. So that's bute, and because ketones end in anone, this becomes butanone. Okay, and obviously this one is also called butanone. It's the same molecule. Yeah, same molecule. Now, the issue arises when we get bigger than butanone, and this is the note that I wanted to make. Okay, so when the ketone has more than 4 carbons in a straight chain, we need, okay, big need, we need to name the position of the carbonyl group. Okay, and it'll make a wee bit more sense when I give you examples of this. So let's go for this one. 1, 2, 3, 4, 5. Put in our H's. Get in our carbonyl group. Okay, now also want you to draw this molecule. So it's 5 carbons in each one, okay, and the only difference between the two is the position of the carbonyl group. Okay, so if we highlight the carbonyl group, yeah, we know it's a ketone because it's in the middle of the molecule, it's between two carbons. If we label the bond, we start from the side closest to the functional group, so that's 1, 2, 3, 4, 5. This one here, because the functional group's bang in the middle, it doesn't matter what side we start from, so I'll just start from the left. So 1, 2, 3, 4, and 5. Yeah? And again, they're both 5 carbons, so they're both going to start with pent. And they're both ketones, so they are going to have a known in it. But what we do, because we can obviously alter the position of the carbonyl group, we need to name the position. So this would become pentan 2 on. Okay, and I hope you can see why, because the carbonyl group is on carbon 2. So this is pentan 2 on. And this one, you should hopefully know, this would be pentan 3 on, because the functional group is on carbon 3. So we've got pentan 2 on and pentan 3 on. And that is how we name ketones. Okay? Now I'm going to do, obviously it gets a wee bit harder with branches, but again, if you can name branches in alcohols, alkanes, alkenes, you can name branches for anything. So let's turn the page, and I'm going to do some examples. So let's just name these two molecules. Okay, we're going to name that one, and we're going to name this one. So again, if you need time to draw these molecules, you can pause the video and just start it when you are ready. Okay. Right, so going to name these two molecules. We'll start with the first one. Again, highlight your functional group, locate where that is. Okay, so that's the carbonyl group, which is the C double bond O. And because it's in the middle, yeah, it's in the middle of the molecule, it's between two carbons, you should be thinking to yourself, right, this is a ketone. Okay? Now, start from the side closest to the functional group, which is the right side, so that's carbon 1, 2, 3, 4, and we've got a branch on carbon 3. Okay, so if we name the longest chain first, that's 4 carbons, so that's bute. And because it doesn't matter where the carbonyl group could only go there or there, it would be on carbon 2 regardless. So because it's bute, this would just be bute unknown. There's no point, you don't have to name, you don't call this butane 2-on, because there is only one position at this carbonyl group can go. Okay, the methyl group is on carbon 3, so this is 3-methyl butanone. Okay, and that's it. This one will be a bit more trickier, but the same rules apply. Locate your functional group, there it is. It's a C double bond O, so it's a carbonyl group, and because that carbonyl group is between two carbons, this is a ketone. Okay, start from the side closest to that functional group, which would be the left, so that's 1, 2, 3, 4, 5, 6, and 7. We've got a branch on carbon 4, and we've got a branch on carbon 5. They're both methyl branches, so we've got 2 methyl branches, so that would be dimethyl, but we'll come on to that. So name the longest chain first. So we've got 7 carbons, so that's hept for 7. And because it's bigger than 4 carbons, the longest chain, we can have a variety of positions of this carbonyl group, so we need to name the position. So because it's on carbon 3, this would be heptan dash 3 dash -one. Okay, so this is heptan 3-one. Now we've got a methyl branch of carbon 4 and a methyl branch of carbon 5, so this would be 4, 5 dash dimethyl. Okay, di meaning 2, methyl meaning a branch with 1 carbon. So this molecule is 4,5 dimethyl heptan 3-one. Okay, and that is how we name ketones. So let's recap, because we've done quite a lot today. So we've learned about the 3 types of alcohol: primary, secondary and tertiary. Primary alcohols are when the carbon attached to the hydroxyl group is attached to 1 carbon. Secondary alcohol is when the carbon attached to the hydroxyl group is attached to 2 carbons. And tertiary alcohols are when the carbon attached to the hydroxyl group is attached to 1, 2, 3 carbons. Okay, so you need to know that. You need to know how to identify your primary, secondary and tertiary alcohols. Then what we went on to is we went on to aldehydes and ketones. Okay, so again, there are another 2 types of homologous series. What's important about them is that they both contain this carbonyl functional group, which is a C double bond O. Okay. In aldehydes, the carbonyl group is found at the end or the start, depending on the way you look at it, of the molecule. Okay, and that's your 2 examples there. They're always found at the start of the molecule. Remember, methanol is an aldehyde because it is at the start, yeah? And aldehydes end in the word anal. Okay, so ethanol, pentanol, methanol, and then obviously if you get branches, you need to start naming the branches. So that's 3-methyl-butanol, 4-ethyl, 5-methyl-hexanol. Okay, aldehydes are quite easy. Ketones, it gets a wee bit more complicated, but it's still self-explanatory. Okay, so ketones, the carbonyl group is found in the middle of the molecule between 2 carbons. Okay, and that's important. Yeah, and then the smallest ketone we can have is propanone, because obviously you need to have a carbon either side, so you need minimum 3 carbons. Yeah, ketones end in this word anone, so because that's 3 carbons, that's propanone. Because that's 4 carbons, that's butanone. Okay, it's only when we get bigger than 4 carbons, when we get to 5 carbons, 6, 7 and 8 carbons in the longest chain, that's when we need to start naming the position of the carbonyl group. Okay, so because the carbonyl here is on carbon 2, that's pentan 2-one. Because the carbonyl group is on carbon 3, that is pentan 3-one. And then obviously you can start naming your branches, blah blah blah. Right, that's us. So take all that in. Make your notes. You should be making notes as we go through this. I'm going to put up some questions on Teams for you to work through, and then tomorrow Mrs. Clark is going to do a wee experiment with you, a demonstration. Okay, right. Thank you.